Hey everyone, in this video today, I'm going to spend a little bit of time talking about survey measurement and design basics. So as we head into the end of this class where we are going to be talking more about how to design epidemiologic studies, I want to actually backtrack to this content that we skipped because of our extended spring break earlier this semester, because a lot of the issues that come up in survey measurement and designing surveys are relevant to epidemiological studies in general. So I want to make sure that you have this background before I jump into talking about how to design specific studies. So we will be talking about error and different sources of error in survey research. I'll define what validity and reliability mean and talk a little bit about the different types of validity and reliability. I won't go into so much how to interpret them, but I will mention that briefly, and I'll link to a document that does that in more detail that's posted on the class website. And I will also spend a few minutes talking about what characteristics of questions might make it more likely to be a valid measure. So let's first talk about error and what error is. So error is a mistake, just like in regular life. A systematic error is the kind that we worry more about in research and in collecting valid and reliable data. So a systematic just means there's a pattern to it that we can predict it, assuming we know what to look for. In other words, it's associated with some characteristic of people in the sample, or it's associated with the measures in some way. So systematic error results in bias, and that's why it's such a concern. Bias means that our estimate is farther away from the truth than we would like it to be. We're always trying to estimate the truth, a population parameter, what actually is going on in a population. And so bias is anything that moves our estimate away from that truth. So systematic error is one way that we can get bias. There are lots of different examples of this. The one that I have here is, maybe you have multiple interviewers collecting data. And one of these interviewers, were interested in smoking among women who are pregnant. And so instead of asking the question, do you currently smoke, or how many cigarettes do you currently smoke, whatever is actually written in your survey, maybe this one interviewer says to women, you don't smoke, right? Clearly that's a leading question, and it's going to bias responses, because even if a woman does smoke, she may feel like she should say no to that question because it's asked in a leading way. It's leading the woman to say, no, I don't smoke. So that would result in systematic error. That interviewer's responses would be different from other interviewers' responses in a predictable way. That interviewer would be more likely to have more no responses than is true. So that's an example of bias. Anytime that questions are asked in a different way, or methods are different for one group versus another, maybe it's even recruiting. Maybe there are instances of people structuring incentives for participants based on their income level. So that might result in systematic error. You may get more people from the group who are getting higher incentives, which would then not be representative of the full sample. Random error is also problematic, but less problematic because it doesn't necessarily result in bias. So random error means that there's the same amount of error or the same chance of error across everybody. There's not a particular pattern to it. So one example is, maybe your tool isn't good. So if you're using a scale, if you're collecting weight to calculate BMI, and maybe there's just one scale used in the study, or maybe all of the scales in the study were miscalibrated at the factory, and so everybody's weight is off by 1/2 kilo. That's a problem because it's not true. We're misestimating people's actual weights, but at least it's the same across everyone. So if, for example, we're looking at change in body weight, the change would be accurate and the change would be consistent across people. It's just that our scale wasn't perfect to begin with. So the problem with random error is that almost certainly our estimates will be less precise or farther from the truth. And so it can actually make it harder for us to see true relationships when they're there. So it's basically a type of measurement error that can result in what we call attenuated estimates. So we might fail to reject the null hypothesis more often than we would have if we'd had accurate measurement tools. And also just thinking about why these topics are important, not just from a measurement perspective, but why are they important in public health practice? And really it's because we use survey research methods, we use measurement tools so often to understand the health of populations and to make evidence-informed decisions. So we want to use the data that we collect to make decisions about how to allocate resources, whether or not to implement programs and services. And so it's really critical that we get things right, that we're getting valid and reliable estimates from the surveys that we produce. So lots of surveillance systems that we talked about, like the behavioral risk factor surveillance system, is entirely based on a telephone survey. There are other examples like that. And even other sources like registries and longitudinal studies may have some component, and things like the National Health Interview Survey or National Health and Nutrition Examination Survey, NHANES, sorry, even though they involve some component where they actually interact with people and take measurements on them, they typically still involve some kind of survey component. So it's a major contributor to the evidence and data that we have in public health. And I think, there is this perception, and certainly it is true, that anyone can design a survey. As things like SurveyMonkey, Survey Gizmo have become more available, it's possible and pretty easy to just put together your own survey and send it out to a bunch of people. But I think we've all probably taken surveys where it's clear that the questions are not very well designed, they're not clear, they ask multiple things in a single question, they don't give you adequate response options. So yes, anyone can design a survey, but if we want to design a survey that's accurately capturing information, it's a little bit more challenging, and it takes thinking about several components. So typically in class, when we cover this topic, I ask you all to design a survey to measure nicotine exposure among US adults. So take a minute now, you can pause this. I'm not going to wait too long, but think about what question or questions you would want to use if you were trying to measure nicotine exposure among adults. We'll come back to this later. But for now, I'm going to move ahead, and we want to think about three main components when we're talking about survey research and trying to do research, collect data in a way that is most likely to be valid. So it's about the questions that we include, and we'll be talking quite a bit about that. It's also about the sample. So I will only briefly touch on sample. I assume you talked some about sampling in biostats last semester, but certainly we need a sample that's representative of the population we're trying to understand in order for our data to be meaningful. And then we also need to use data collection methods that are most likely for us to maintain that representative sample and also get responses to our valid and reliable questions. So all three of these are important to have and to think about as you design a survey. So let's briefly talk about samples. Random sampling is ideal because it's the most likely type of sampling approach to give you a representative sample. So if we are selecting people into our survey without regard to their personal characteristics or where they live, then it's more likely that they will then look like the true underlying population, because as we've talked about before, it's very difficult, time intensive, expensive to survey every single person in a population. We attempt to do that with the census. That's the closest we get. But even with that, we talked about how there are groups who are not fully represented in a census, but pretty much every other data collection effort is a sample of the population. So there's simple random sampling, which is shown at the left here. And there's a link at the bottom to a YouTube video that's a nice explanation of all these different kinds of samples. And that's also where I took the images from. But simple random sampling means you've listed every person in the population. Every single person has exactly the same probability of being selected into your sample. Very hard to do. You need a list of every person in your population, which isn't always available. But that's a simple random sample. There are other types of random sampling. So a stratified sample means that you break your population up into groups, and then within those groups, you do a simple random sample. And the benefit of a stratified sample is if your population, oftentimes we're in a situation where there are different subgroups within our population and they're not equally sized. So if you were just worried about males and females, typically that's about 50-50. So a simple random sample would still give you an adequate number of both groups. But if you're interested in looking at a health outcome based on something like race and ethnicity, there are clear differences, especially by generation, in the distribution of race and ethnicity in the US. And so you might want to stratify your sample by those different racial and ethnic groups so you assure you get enough people in your study who are, for example, of Pacific Islander descent. Because otherwise, if you just take a simple random sample, you might end up with too few Pacific Islander respondents, and you wouldn't be able to have the statistical power to say anything about that group. There's also clustered sampling. This is usually clustered by geographic region. So for example, if we want to understand health among elementary age students, one way to do that survey is rather than just taking a random sample of all students in our county, we might randomly sample clusters like schools. So we could at random select 2 or 3 schools from the county. And that allows us to really focus our efforts, get the word out about the survey, try to get a higher response rate from those randomly selected schools. In a small county like Watauga, that probably doesn't work so well because we only have a handful of elementary schools and they all have pretty different characteristics. But in larger cities, that might be a good strategy. You could also you could do clustered sampling by neighborhood if you were able to enumerate every neighborhood in an area or across the county, then randomly sample neighborhoods and do surveys within those. That's another way to do clustered sampling. The last one is systematic sampling, and this is listed as a random sampling approach, and it can be, but it's important to think about what your system is. So for example, a systematic, well, let me define it first. A systematic sample just means you take every X person from the population. So one example of when it would still potentially result in a bias sample or would still result in a bias sample, let's say you're sampling through a healthcare system and you decide that you're going to sample every 4th person who has an appointment with the primary care physician. So imagine that your population of interest is primary care patients. So it's not necessarily a problem that's our pretty limited sampling frame. But the problem would come in if every 4th appointment, many physicians do schedule 15-minute appointments. So that means it would be the last appointment of the hour every time. And maybe this clinic holds that for people who have diabetes, let's say, and that's the appointment slot reserved for people who need blood glucose checks or who need some other kind of care related to diabetes. So if that were the case, your sample would entirely consist of people with diabetes, and that would clearly not be random any longer. So you just need to make sure that there's not an underlying pattern that kind of overlaps with your systematic sampling approach if you try to do this. The other broad category, the non-random type of sampling, we typically just refer to this as convenient sampling. So it's just people, if you're standing on a street corner, or if you set up a table in the union, or if you send out an email to a list of people who are members of some organization, that's a convenient sample. You're reaching people based on some connection with them, some ease of recruiting. So it's possible that this still could be a random sample, but in all likelihood, there's going to be some kind of bias because there's something about those people that make them all easier to reach. So it's more likely that a convenient sample is going to be a biased sample, that it's not truly going to represent the underlying population. Okay, so that was the sampling part, one of the things that you need to be concerned about in survey research. The next thing I want to talk about is the questions. So actually writing questions that are both valid and reliable. So you may have talked about validity and reliability before in other classes, but in case you haven't, I want to cover that in some detail here. So validity is talking about how close to the truth your measure is. And there's different types of validity. This is not an exhaustive list here, but these 3 types are ones that I commonly think about that people who do tests to see whether or not a measure is valid often report on. So face validity is kind of the easiest, just look at it and see if it seems like it makes sense. So, if our measure of, remember we were trying to think of a measure of nicotine exposure for adults, if one of the questions is asking about workplace, That is not immediately obviously connected to nicotine. And so face validity for a question about what industry do you work in would not have high face validity for measuring nicotine exposure. So in order to have high face validity, you want it to be clear that the question is connected to the topic that you're trying to address. Construct validity means that you're only measuring one construct, which is kind of a dimension or an attribute of whatever health characteristic that you're interested in. A lot of times this could be based on some kind of theoretical model or framework. And if you're reading an article and they talk about doing a factor analysis or using item response theory, usually what they're trying to get at is their construct validity? Does this question align with some known or theorized dimension of the aspect of health that we're looking at? So for example, if you're thinking about social support, there are different types of social support. So there's instrumental support. There is, of course, now I'm blanking on the other kinds of social support that we usually talk about, but there's different domains of social support that we'd want to measure. And so in a question about social support, you wouldn't want to ask about both emotional support, let's say, do you have someone you can talk to when you are experiencing a crisis or feel lonely? That might get at, kind of emotional support. And we wouldn't want to link that to something like tangible support, which is, do you have somebody who could pick you up if your car breaks down? Or do you have someone who could lend you money if you don't have enough money to buy groceries? So those are two different kinds of social support. And so we wouldn't want to put them together in a single question where we say, do you have somebody who's there to help you if you're feeling down or to give you money if you run out of money? Those are two different constructs. So to put them in the same question is problematic. In general, one way to make sure that you're not asking about multiple constructs is to make sure that all of your questions only ask about one thing. So even if you don't think of those two different things as multiple constructs within the broader idea of social support, if you have an and in your question, you should seriously consider breaking it into two parts. The last type of validity I'm going to mention here is criterion-related validity. And this is where you take your measure that you've created and compare it to one that already exists. So there are lots of validated measures in existence in the world, things that have already gone through substantial testing, been used a lot of times in other studies. For example, there are a number of measures of quality of life and general health. So the SF-12 or SF-36, there's different lengths of this item. But this SF measure is a measure of general health. And so if you're trying to measure something that you think should overlap with health, if you're trying to measure somebody's, their chronic health condition burden, for example, you would expect that to overlap somewhat with this general health measure. And so you could compare your measure to an existing measure. And to do that, you would have to ask both of them in your survey. So ask your questions, ask the SF-12, or whatever this other validated measure is. So you can see how do your responses compare to this existing response. So that's a way to show your questions are valid, that they're doing what you expect them to do because they kind of align with or match up with this criterion-related measure. The other major measurement aspect that we think about when we look at questions and whether or not they're good questions is reliability. And reliability means being able to replicate or get the same result over and over. So validity is getting close to the truth. Reliability is being able to get the same answer multiple times. And again, there are multiple types of reliability. Not all of them are listed here, but again, these are the ones that I think are kind of the most common. First is internal consistency. And so this tells you whether a person's responses are similar across items that measure the same construct. So this is kind of similar to that idea behind the criterion-related validity. If I'm asking people to tell me about their chronic health conditions and also to rate their health overall, you would expect there to be some consistency between those types of measures. Generally, chronic health conditions are associated with health status overall. It's a component of overall health. Certainly, they don't perfectly correlate, but you would expect to see some consistency there. Likewise, if we're asking somebody about depressive symptoms and we have a question where we say, in the past 30 days, how many days was your mental health not good? And let's say they say 17 days. So most of the past month, they felt like their mental health was not good. And then if you have a series of more specific questions where you say, in the past 30 days, how many days did you feel sad, blue, or depressed? And how many days did you feel like you didn't have energy? Or how many days did you feel like you had difficulty doing anything that brought you pleasure? If they said 0 on all of those, it wouldn't really match up with the idea that they had 17 days of poor mental health, but didn't experience any of these specific kinds of symptoms or manifestations that we associate with depressive symptoms. So that's internal consistency, that the person's responses are consistent within themselves, within their own answers. Retest reliability means if you give somebody the same questions, they answer in about the same way at 2 different points in time. Now here it's important to think about what time frame makes sense. Of course, something like depressive symptoms can change pretty dramatically depending on someone's life circumstances. So, you might not want to test it 6 months apart, but maybe a week apart you'd expect. Depressive symptoms probably don't change that dramatically over a week, so you'd expect to see about the same responses at the 2 different time points. Another type of reliability to look at is intra-rater reliability. So we don't just want to look at the person, the respondent, and their information, but if somebody else is collecting data about them, through an interview or something, or through observations, we want to make sure that the person doing the rating is consistent. That if I watch you check your blood glucose, at 2 different time points, that I am, rating you in the same way on how well or how closely you do that checking to whatever your physician has told you to do. And then inter-rater means between raters. So again, if you have 2 different people going out and doing measurements, for example, let's say you're looking at neighborhood quality, you'd want to make sure that my measurements match up pretty closely with the other person's measurement. So the way that we often do this is to do consistent trainings across raters. So everybody goes out together and does ratings and does some practice together. And, the creating manuals and things that have very clear instructions about what constitutes a different score is a way to increase inter-rater reliability. So we want to make sure that we're not introducing systematic bias into our data by having different people collect information. So generally, before I talk about the bullseye, for both validity and reliability, often what you'll see is essentially like correlation coefficients reported for these. So the scale for that is typically 0 to 1. Well, it is 0 to 1 for correlation. So 0 correlation means there's no agreement between 2 different measures. So that's bad in this context. 1 means perfect agreement. So there are different scales, but I generally tend to think 0.8 or above means excellent. So if you get an internal consistency of 0.8 between 2 measures, or if you get a criterion-related validity estimate of 0.8 between our measure and the existing valid measure, that's a really good measure, good sign. 0.5 to 0.79, 0.5 to less than 0.8, or well, let's say 0.6 to 0.8 is pretty good. So still promising. 0.4 to 0.6, I'd say, is moderate. I'm not very well convinced that that's a good measure, and anything below 0.4, I would say, is not good at all. So again, people interpret those measures a little bit differently, but the higher the better is the point. The higher correlation between things, the better the measure is. And there are different kinds of tests. I'm not going to talk about what each one of them are, but they're different tests, but essentially they all are a type of correlation. Okay, so let's talk about this figure here. You may have seen this before as well, and these different bullseyes essentially represent how valid or reliable different measures are. So if we think about the central part of this bullseye as being the truth, so the red dot is the truth, and that's where we want our measures to be. The first picture on the left here represents a measure that's reliable. So there's not a lot of error in it. You're getting consistent responses, but you can see it's pretty far from the bullseye. So you might have high inter-rater reliability and high internal consistency, but it's still not a valid measure. So some of those scores would probably be lower if you were looking at the validity. It's far from the truth. The second example here is valid. So by that, I mean, so it's kind of this scattershot looking image, but on average, you would be close to the truth with this measure, but it's not reliable. So you're not getting the different estimates at different points in time would be all over the place. So it's not consistent. You wouldn't have high values for reliability measures. The next one is not reliable and it's not valid. So this is kind of the worst case scenario. On average, you would not end up near the bullseye, and there's a lot of variation in the measures. So low validity and low reliability. And then the last one on the far right is what we're looking for. So all of our measurements are clustered around the truth around our bullseye. So that would give us the result that is useful. It's both valid and reliable. So high measures the kind of 0.8 or above on both the reliability and validity estimates. So this slide has a link to a document where I walk through a study that evaluated a measure of social support. So they created a new measure of social support specific to a condition and compared it to other measures of social support. And really the steps in evaluating whether or not a measure is good and thinking about whether you should use it or not is to look at the tool. So you want to know what it's designed to measure and make sure it aligns with your purpose. If you're looking at an article, that usually comes on pretty early in the intro or methods. Look at how well the measure fits with existing theory. So this is probably in the methods. Then look at how valid and reliable the measure actually is. This should show up in the results section. And then you can make a final decision about whether you think it's a useful measure for you. So this is mostly going to be on your own. The authors will probably talk about it some in the discussion, but they also may, if they've created it in particular, they think it's a good measure. I would encourage you to do your own critical thinking about it because you may not always agree with the author's assessment. And the one thing I should say about where these pieces are in articles, this is assuming that you're looking at a paper that's specifically focused on evaluating the validity and reliability of a measure. So if you just do a PubMed search for, let's say, nicotine exposure, a lot of what you're going to come up with is studies that are looking at, the health impacts of nicotine exposure, or for what groups is nicotine exposure different. There's a function within PubMed where you can look at the type of article. In the old version, I was at the top left of the page. You can limit it to things like clinical trials and observational studies. But one of those options on the list is to limit your results to validation studies. So if you do that, you'll actually get articles that are just focused on the measure itself. So how good is this measure at doing what it's designed to do? So if you're ever looking to put together a survey, that's what I'd recommend. You can see what measures other studies commonly use, but you can also do your own literature search and again, search for validation studies within PubMed, and that'll give you some measures themselves. Okay, so the last thing I'm gonna mention is that the mode of administration does matter. So different options, you could do paper and pen surveys, you can call people on the phone, you can let folks do surveys on their own over the internet or on a computer, a tablet, something like that. And you can have a person interview them face-to-face. And that person may be using a tablet or a computer to enter responses. But there actually are differences in terms of what people will tell you and what questions they'll answer based on the mode of administration. And so it's good to do a literature search on your particular topic. In general, the evidence shows that if people do a paper and pen survey or do a computer-based survey on their own, they're more likely to skip questions. And if they're talking to an actual person, whether it's on the phone or via interview, they're more likely to at least answer all of the questions. So that's one thing to be aware of. And this may surprise you. I usually ask your opinions in class, but oftentimes we actually see people being more willing to talk about sensitive subjects like sex and illicit drug use over the phone rather than in-person interviews or even on pen and paper. So those are the kinds of questions, if people feel like there's a legal ramification, they often skip those questions on, or more often skip those questions than other types of questions on pen and paper or computer administered surveys. But if you ask them, but you're not sitting in front of them, they're more likely to answer them and answer them truthfully. Like we talked about early in the semester, anytime you're writing things for a general audience, and this includes survey questions, make sure that you're clear, that you use as low a reading level as possible, avoid jargon, only ask one question at a time, and also give people a broad range of response options. So again, even if you're not intending to lead people to a particular answer, if you say, for example, let's say you're asking about illicit drug use and you say, in the past month, how many times have you used whatever drug? Let's just say it's cocaine that you're asking about. So you've already asked people whether or not they used cocaine in the past month. Those who say yes, you want to know how frequently. And if your response options are once, twice, 3 times, 4 times, and 5 or more times, those people who use every day are going to be in the 5 or more category, which is problematic because it's probably not wide enough anyway. But people tend to like to feel like they're kind of average. They're kind of in the middle when they're answering these kinds of questions. So even if 5 or more is true, they might say 3 or 4 times just because your response options were so clustered at the low range. That gives them the cue that, oh, I use way more than other people, so I should probably underreport a little bit so I'm kind of more in line with the average. Let's see. Yeah, and the order of the questions matters too. So I think a lot of people still tend to start off their surveys with basic demographics, thinking that it's kind of the easy questions. But studies show that it actually is generally better to put those at the end of the survey, because people do get a little bit burned out by the end of surveys. So even if we see those as easy questions, it's nice to have those saved for the end. The other thing is that if you're missing data, you probably want to be missing those rather than content questions. And also sometimes people, once they've, even if it's just a paper and pen survey or a web-based survey, they might feel like they've already disclosed all this other information. And so they may be more willing to share their personal details by the end of it than they were at the beginning of it. So usually putting demographics at the end is a better strategy. And you can also, but in terms of topics, you could start with kind of less stigmatized topics at the beginning, like general health and overall well-being, maybe social support, and then move into things that are a little more personal later in the survey. I will just say one quick thing. So even if you have come up with a beautiful sampling strategy that will be representative of the population, if your response rate is low, then your survey may still, or your sample may still end up being biased. So you want to make sure that not only do you do a good job of identifying an appropriate sample, but getting those people who are then sampled to respond. So you want as many people as possible, as high as possible a response rate. And make sure, again, that it's not different for different groups of people. So you should have the same kinds of strategies to get people engaged, or if they're different, there should be a strong rationale. If you're doing a full community-based sample, you'd have to think about, how do we get people who are homeless to participate at the same rate as people who have a home? How do we get kids who aren't in public schools to answer at the same rate as kids who are? How do we get all these different groups of people to have the same response rate so we don't end up with a biased sample? And even though I said before it's probably not a good idea to offer different incentives for different groups of people, there may be different, in terms of like value of incentives, there may be different types of incentives that are more appealing to different people. So some groups may be fine with cash, some may prefer a gift card, some may prefer some other type of incentive. So just think about what's going to be useful to the people that you're trying to encourage to respond. And you should always look at who has and hasn't responded to your survey, because that can give you important clues about whether or not it's actually representative. So just as an example, this doesn't look very clear on my screen here, so I apologize, but for the behavioral risk factor surveillance system, there's not just, when an interviewer calls somebody, there's not just a, oh, did not respond. There's actually different codes depending on why that person didn't respond. So the first two are pretty straightforward. There are people who were interviewed and those who did all questions versus those who stopped the interview early. But even for those who were eligible, they further break it down into whether the person answering the phone refused, whether the actual respondent who was then selected refused, whether there was somebody who was not able physically or mentally to do the interview, or if there was a language barrier. So again, if you can distinguish why people didn't participate, that can help you understand how your sample may be lacking, and it can also inform future survey efforts to try to overcome those barriers. And I just want to mention that response rates are pretty low for telephone surveys overall. You can see that some of these, like the California Health Interview Survey is the first one listed on here. The response rates estimated here are 12% for landline and 10% for cell phones in 2015. The BRFSS is above 40%, but that's still less than half of the people who are eligible actually participate. So it's problematic. And there are ways to kind of replace the people who were initially sampled. So it doesn't mean that all of these samples are not representative, but it does mean you're going to have to work hard to get people to respond and to keep that sample representative. So coming back to our earlier question about how should we measure nicotine exposure, all of you are pretty savvy at this point about how to measure things and what components we might want to think about. So when we're talking about something like nicotine, the obvious exposure route that comes to mind is individuals smoking. And of course, we know now that just asking about cigarette use is probably not going to be enough. So there's both e-cigarettes, there's different types of pipes, and you need to use different language depending on your population. Whereas older adults might think about a pipe being the traditional, nicotine kind of pipe that people used to use. People using water pipes may not identify it that way, so you may have to specifically use different language and labels to get an accurate measure of how people are using nicotine. But you also want to think about other exposure routes. So it's not just individuals using it themselves, but my example before did mention workplace, and now that there are so many bans on smoking in public places, and private businesses, we don't have nearly as much secondhand exposure, but there are still industries and situations in which people would have high nicotine exposure at work, including manufacturing nicotine delivery devices themselves, or managing nicotine. But you want to be creative and make sure you have an exhaustive list of all the different ways that someone might be exposed to nicotine, so you're getting an accurate measure of that. So just a reminder that you need to be sure, as the person putting together the survey, that you're aware of all the different routes of exposure and that your survey covers all of those different routes. So next, I will be recording a video talking about some study design, but again, I wanted to give you this basic measurement background before we jumped into that. So I'll talk to you soon.